One of the things that's going to help with graphing of quadratics is going from vertex form to standard form. There are a couple different ways that you can do this, but I'm going to show you in that we have our vertex form and we don't necessarily need to truly complete the square. We'll talk about that later, but let's say, for instance, that I have the equation y minus 3 equals 2x plus 4 squared. So when I'm looking at this, I want to change this into true standard form. So the first thing I'm going to do is I'm going to move that k, or the -3, over. So I've got y equals 2 times x plus 4 squared plus 3. So now what I'm going to do is I'm going to expand that x plus 4 squared. So I really have then 2 times x plus 4 times x plus 4 plus 3. So I'm going to have to use some distribution, or I can technically use the square of the binomial in order to expand that x plus 4. I'm just going to go ahead and distribute. So I will have x squared plus 4x plus 4x plus 16 plus 3. In case you're curious of how I got that, sorry, I was doing that in my head. X times x gives me x squared. X times 4 gives me that 4x. Now do the bottom part. So I'm going to combine like terms as well as multiply by that 2. So I combine my like terms, and I'm going to multiply by that 2. The 2 only goes to the stuff in the parentheses. And finally, I'm going to add that 3. So y equals 2x squared plus 16x plus 35. Now, when I'm in this form, I might not be able to see where my vertex actually is. That's okay though, because you were started in vertex form, so you know where your vertex should lie. This just allows you a better idea of where your zeros will fall, as well as typing it into your calculator will be a little bit easier with that. What I was talking about earlier about completing the square, that's when we are going from standard form into vertex form. So you guys will only be presented right now with vertex to standard. If I were to look at the graph of this, I could find my vertex and I could find my x and y intercepts. It all just depends on what you're specifically asked for. Another application for quadratics is when we're talking about something falling, or if we're throwing a ball up in the air and then it's coming back down, for instance, like a basketball when you're shooting a basketball. There is something to note that we need to talk about the acceleration due to gravity. This equation is going to be in the form of h equals -1/2 g t squared plus the velocity times t plus the height. Depending upon what you are using in terms of your units, this could alter just a little bit if you're dealing with feet or if you're dealing with meters. G is going to be either 32 feet per second squared or 9.8 meters second squared. Like I said, it just depends upon what you're dealing with in terms of units. The VO is your velocity, and the HO is your height. For right now, just take notes on this. We will go through an example together in class. That way you guys have a better understanding, and that way you know where everything is going.